Let us see properties of autocorrelation function for stationary random processes. That means particularly wide distance stationary random processes. So autocorrelation function is given by expectation of xt x of t plus tau. So what is this? This is the random process observed at t instant, and this is the random process observed at t plus tau instant. So this is nothing but the autocorrelation, which is dependent on the time difference tau only. So autocorrelation function doesn't depend on the individual instances, but it is dependent on the difference between that instances. Next, autocorrelation is a even function, that is rxx tau is equal to rxx minus tau. Then rxx mean square value of random process is equal to rxx 0. So how you got this? If you put here tau is equal to 0, then you will get rxx 0 and you will get ex square t, and ex square t means total power. Total power is equal to mean square value is equal to rxx 0. Maximum value of the autocorrelation function is rxx 0. Then if random process xt is non-periodic, then its autocorrelation function is also non-periodic. If random process is periodic, then autocorrelation function is also periodic. For ergodic random process, because we have already discussed that wide sense stationary random process are nothing but the stationary random process, and ergodic are also the stationary random process. So the mu, or if it is ergodic, then only mu x square, that is dc power, is equal to rxx infinity. So always keep in mind that for the stationary random process, total power, that is E mean square value, that is E x square t, is equal to Rxx 0. And for if it is ergodic, then mean square value, that is dc power, is equal to what? It is Rxx infinity. One equation you have to keep in mind, that E x square t is equal to sigma xt square plus mu xt square. So total power is equal to AC power, that is variance, is equal to plus DC power. So next, cross correlation we will see. Cross correlation, that means you have to observe the random process, two random processes, one is xt, another is yt, or xt is observed at t, yt is observed at t plus 2. Then you will get the cross correlation function. So how to write the cross correlation function? You have to in the subscript you have to write x first, then y, and then you have to take the difference t plus tau minus t. But while taking the difference, you have to subtract first from the second. Now let us see how to write this one, yx. So first write y, then x, then second you have to subtract first from the second. So t minus t minus tau, that is equal to minus tau. Here also similar, x y. So first write x, then y, then subtract t plus tau minus from t. So t minus t minus t minus 2, that is rxy minus tau. Here yx, so y and x is written. So t plus tau minus t is tau. So from this we can observe that this is similar. So rx by tau is equal to ryx minus tau. So for cross correlation, this is the symmetry, that Rx by tau is equal to Ryx minus tau, and Rxx tau is exact value is Rxx 0 plus Ryy 0 divided by 2, and it is always less than square root of Rxx 0 into Ryy 0. So what is this Rxx 0? It is the autocorrelation function of the random process x at 0. This is autocorrelation function of random process y at 0. So this is it for the properties of the autocorrelation and cross correlation function in case of the stationary random processes.